Hello students, welcome back to online lecture of 12th Maths first. Topic number 5, Vectors. Student, in the last video we had started topic vector. We had seen what is the vectors, types of vectors and algebra of vectors. In that we had seen triangle law, parallelogram law, all these law we had covered. Now we will see some theorems based on this topic. So let's start today's video. Theorem first. Two non-zero vectors a and b are collinear if and only if there exist non-zero scalars m and n. At least one of them is non-zero, such that ma bar, see here, ma bar plus nb bar is equal to 0 bar. Okay, see students, two non-zero vectors a bar and b bar are collinear. When they are collinear, if there exist m and n such that it satisfies this condition, ma bar plus nb bar is equal to 0 bar. म्हणजे तुम्हाला लक्षात काय ठेवायचं आहे, दोन वेक्टर्स कोलिनियर असतील तर काय कंडिशन येणार आहे, एम ए बार प्लस एन बी बार इज इक्वल टू 0 बार. त्या दोघांपैकी एक नॉन झिरो पाहिजे, एम किंवा एन. ओके, वी विल सी प्रूफ. लेट ए बार अँड बी बार बी टू collinear vectors. Therefore, they are either in the same direction or in the opposite direction. Collinear means they are in the same direction or they may be in the opposite direction. Okay, first we see when they are same directions. Let a bar and b bar in the same direction and e bar is the e cap is the vector along them. Then you know by the definition of unit vector, e cap is equal to a bar upon magnitude of a bar, where e cap is unit vector along a bar. Similarly, e cap is unit vector along b bar, so you can write e cap is equal to b bar upon magnitude of b bar. Okay, therefore observe these two equations. This is the first. Okay, see these two equations. From these two equations you can write a bar upon magnitude of a bar is equal to b bar upon magnitude of b bar. Cross multiply, we get a bar into magnitude of b bar is equal to magnitude of a bar into b bar. You take a bar b bar on the LHS, so we get b magnitude of b bar into a bar minus b bar into a bar is equal to 0 bar. We suppose this magnitude of b bar as m and magnitude of a bar as n. Okay, so we can write m a bar plus n b bar is equal to 0 bar, where a bar and b bar are non-zero scalars. So we take first condition that a bar and b bar are in the same direction. Now we see a bar and b bar are, second case, in the opposite direction and e bar is the unit vector along a bar. So unit vector along b bar is minus e cap. Okay, because both a bar and b bar are in the opposite directions. So we get e cap as a bar upon magnitude of a bar and minus e cap as b bar upon magnitude of b bar. So from these two equations you can write a bar upon magnitude of a bar is equal to minus b bar upon magnitude of b bar. Similarly, same procedure, cross multiply, you get magnitude of b bar into a bar is equal to minus a bar into b bar. Take these two LHS, magnitude of b bar into a bar plus magnitude of a bar into b bar is equal to 0 bar. We suppose here b bar as m and a bar as n, so we get m a bar plus n b bar is equal to 0 bar, where m and n are non-zero scalars. Okay, very easy. Hence we prove both the condition. For both the condition we prove both the cases. We had proved m a bar plus n b bar is equal to 0 bar. Okay, now we will prove conversely. If m a bar plus n b bar is equal to 0 bar, where m and n are scalars, then we have to prove that a bar and b bar are collinear. We have to prove. So from this you write m a bar is equal to minus n b bar. Okay, m is not equal to 0, so you can write a bar is equal to minus n upon m into b bar. That is, we can write a bar is equal to k b bar, where k is constant, minus n upon m is a non-zero scalar. Okay, so here k is positive real number, then b bar and k b bar are in the same direction, so a bar and b bar also in the same direction. If k is negative number, then b bar and k b bar are in opposite direction. So in the both the cases, we prove that a bar is equal to k b bar. So one vector can be expressed as scalar multiple of another vector, means they are in the same direction or opposite direction, maybe. Okay, but one vector is scalar multiple of another vector, so this implies that a bar and b bar are collinear. Okay, so when the vectors are collinear, when one can be expressed as scalar multiple of another, that is, if we express a bar is equal to k b bar, then we can say that from this you can say that a bar and b bar are collinear. Okay, so collinearity condition काय बघा, collinearity काय condition आली, m a bar plus n b bar is equal to 0 bar, then a bar and b bar are collinear. And conversely, if a bar and b bar are collinear, then m a bar plus n b bar is equal to 0 bar, where m and n are scalars. Now student, we will see corollary based on this collinearity. First corollary is C. Two vectors a bar and b bar are not collinear, and m a bar plus n b bar is equal to 0 bar, then m is equal to 0 and n is equal to 0. You remember the statement of this corollary? If two vectors a bar and b bar are non-collinear, then we write m a bar, and if m a bar is equal plus n b bar is equal to 0 bar, then you write m is equal to 0 and n is equal to 0. See the second corollary. If two vectors a bar and b bar are not collinear, and m a bar plus n b bar is equal to p a bar plus q b bar, then you write m is equal to p and n is equal to q. Okay, you remember both this statement. Now we will see next point is the coplanar vectors. When we say that the two vectors are coplanar, see here these three planes are there. This is first plane, this is second, and this is third plane. In the first plane there are two vectors a bar and b bar. In the second plane there are two vectors c bar and d bar, and in the third plane there is one vector e bar. When we say that these are the coplanar vectors, see, two or more vectors are said to be coplanar if they lie in the same plane or in the parallel plane. Okay, if they lie on the same plane or parallel plane. Observe here, vector a bar and b bar are coplanar. Yes, because they both lie in the first plane. This is the first, second, and third. A bar and c bar, see, a bar and c bar, a bar is in the first plane and c bar in the second plane. These first and second plane are parallel to each other, so a bar and c bar are also coplanar. But observe, a bar and c bar, a bar is in the first plane and c bar is in the third plane. These two planes are not parallel to each other, so a bar and c bar are not coplanar. Okay, understand coplanarity? Now we will see theorem based on this coplanarity. See what is the theorem. If A bar and B bar are non-collinear vectors, a vector R bar is coplanar with A bar and B bar. If and only if there exist unique scalars T1 and T2 such that R bar is equal to T1 A bar plus T2 B bar. Observe student figure first. If A bar and B bar are non-collinear vectors, then R bar is coplanar when if there exist unique scalars T1 and T2 such that R bar is equal to T1 A bar plus T2 B bar. Okay. First you observe figure here. Let R bar is coplanar with A bar and B bar. To show that there exist unique scalars T1 and T2 such that R bar is equal to T1 A bar plus T2 B bar. We let here OA, A bar is the vector along OA bar and B bar is the vector along B bar, OB. Okay. The given vector R bar with initial point O, that is OP bar is equal to R bar. Now we draw lines parallel to OA bar and OP bar. It meet at point M and N. Okay. So we here observe that OM bar is T1A bar and ON bar is T1A bar. Okay. Where T1, T2 belongs to R. Now here we use the triangle law of addition of vectors. R bar you can write from figure you observe R bar is equal to OM bar plus MP bar. OM is T1 A bar and MP bar is T2 B bar. So we write R bar is equal to T1 A bar plus T2 B bar. Okay. Now if part is suppose R bar is equal to T1 A bar plus T2 B bar. And we have to prove that R bar is equal to A bar plus A. We have to show that R bar, A bar and B bar are coplanar. Okay. Suppose as A bar and B bar are coplanar, T1 A bar plus T2 B bar is also coplanar. Therefore, their combination is also coplanar. Means here R bar is coplanar. Hence we prove that A bar, B bar and R bar are coplanar. Okay. Now we prove uniqueness. See, R bar is equal to T1 A bar plus T2 B bar. We can also write as R bar is equal to S1 A bar plus S2 B bar. For uniqueness, we suppose that there exist S1 and S2 such that, okay. So we replace T1 by S1 and T2 by S2. Subtracting equation second from 1, we get 0 bar is equal to T1 minus S1 A bar plus T2 minus S2 B bar. But we had given that A bar and B bar are non-collinear. Okay. So we had seen the corollary first. If A bar and B bar are non-collinear and one way, if A bar and B bar, what is the corollary says? If A bar and B bar are non-collinear and we can express A bar some scalar into A bar plus some scalar into B bar is equal to 0 bar. Then by that corollary we can write T1 minus S1 is equal to 0 and T2 minus S2 is equal to 0. So it implies that T1 is equal to S1 and T2 is equal to S2. That is there doesn't exist any scalars. That proves the uniqueness. Okay. Next theorem we will see is the theorem next. Three vectors A bar, B bar, C bar are coplanar if and only if there exists a non-zero linear combination x A bar plus y B bar plus z C bar is equal to 0 bar with x y z not equal to 0 0 0. Same condition collinear and coplanar condition आहे ती फक्त 3 टर्मसाठी येतं. You remember only this condition. Three vectors A bar, B bar, C bar are coplanar if and only if there exists scalar non-zero linear combination x a bar plus y b bar plus z c bar is equal to 0 bar, where x y z not equal to 0 0 0. Okay. Now student, we will see one new concept. See coordinates of a point in a space. Observe here, one figure is given. Figure, three axes are given, x, y and z. All these three axes are perpendicular to each other. Let P be the point in the space. Draw perpendiculars PL, PM and PN through point P to XY plane, YZ plane and XZ plane, where the point L, M and R fit up perpendiculars. So we get the coordinates of that point P. How we find the coordinates? In the two coordinates XY plane, two coordinate system, you had seen how to find the distance or how to find the coordinates of a point in a plane. But here, how to find the coordinates in the space, we will see. We draw the perpendicular to that plane, xy, yz and xz plane, and we find the points x, y and z. So now we will see coordinates of points on coordinate axis. See here, this is the figure given. Here x, y, z axes are perpendicular to each other. The point, observe student here, the point N is in which plane? XY plane. Okay, sorry, point N is in the XZ plane, so its y coordinate is 0 and x and z coordinates are present. Point M is in YZ plane, so its x coordinate is 0, and point L is in XY plane, so its z coordinate is 0. Okay, and observe point P. Point P lies in the XYZ plane. How to find its coordinate? We draw perpendicular to x, y and z plane and we find the coordinates of point P. So coordinates of points on the coordinate axis. Points on x-axis, then its coordinates are x 0 0. Point on y-axis, then its coordinates are 0 y 0. Point on z-axis, then its coordinates are 0 0 z. And the coordinates of point on the coordinate planes. See, points in the xy plane मध्ये असेल त्याचा कोणता कोऑर्डिनेट 0 असणार आहे? y कोऑर्डिनेट 0 असणार आहे. Then point is in yz plane, then its x coordinate is 0, and in point is in xz plane, then its y coordinate is 0. Okay, understand? You remember all these coordinates of a point on the coordinate axis. ॲक्सिस वर असेल तर त्याचं काय असणार आहे बघा. ए पॉईंट काय आहे तर ॲक्सिसवर आहे, एक्स ॲक्सिसवर आहे, त्यामध्ये जो वाय अँड झेड कोऑर्डिनेट 0 असणार आहे. बी पॉईंट वाय ॲक्सिसवर आहे, त्याचा एक्स आणि झेड कोऑर्डिनेट 0 आहे. आणि सी पॉईंट झेड ॲक्सिसवर आहे, त्याचा एक्स आणि वाय कोऑर्डिनेट 0 आहे. अँड पॉईंट एम एन and L are lies on the plane. So in which plane they lies, that coordinate is present, other coordinates are 0. Next one is the distance of point P, X, Y, Z from the coordinate planes. See, distance of point P from XY plane. P point XY plane पासूनचं डिस्टन्स काय असणार आहे? XY plane मध्ये आहे, मग त्याचा झेड कोऑर्डिनेट जो असेल त्याचं डिस्टन्स असणार आहे. दॅट इज डिस्टन्स पी एल इज इक्वल टू मॅग्निट्यूड ऑफ झेड. डिस्टन्स ऑफ पी फ्रॉम वाय झेड प्लेन, पॉईंट पीचं वाय झेड प्लेनपासूनचं डिस्टन्स म्हणजे काय असणार आहे? एक्स कोऑर्डिनेट असणार आहे. अँड पॉईंट पी फ्रॉम एक्स झेड प्लेन इज मॅग्निट्यूड ऑफ वाय. ओके, Now distance of any point from origin. How we find? Distance of point P from origin 0 0 0. We can find length OP is equal to root OL square plus LP square by Pythagoras theorem. You can write OL as OA plus AL square and LP square, that is OA square plus OB square plus OC square. So we get distance LP. We get distance LP as root x square plus y square plus z square. In this way we can find length OP. Okay, understand student up to this? Next, distance between any 2 points in the space. Distance of any 2 points A x1 y1 z1 and B x2 y2 z2 in the space is given by distance formula. Length AB is equal to root x1 minus x2 bracket square plus y1 minus y2 bracket square plus z2 minus z1 bracket square. Next, distance of point P xyz from coordinate axis. ॲक्सिस वरनं काढायचं आहे. मग कोऑर्डिनेट ॲक्सिस वरनं म्हणल्यावर काय येणार आहे? लेट पी ए इज परपेंडिक्युलर टू एक्स ॲक्सिस, हेन्स डिस्टन्स ऑफ पॉईंट पी फ्रॉम एक्स ॲक्सिस इज गिवन बाय. बघा तो एक्स ॲक्सिसवर आहे. एक्स ॲक्सिसवर प्रेझेंट आहे म्हणजे काय असणार आहे? त्याचा एक्स कोऑर्डिनेट प्रेझेंट असणार आहे आणि वाय आणि झेड कोऑर्डिनेट अब्सेंट असणार आहेत. ओके, सो इन दिस फॉर्म्युला you replace y2 and z2 as 0. So we get PA is equal to root x minus x bracket square plus y minus 0 bracket square plus z minus 0 bracket square. So we get root y square plus z square. Okay. Now student, we will see signs of coordinates of a point P x y z in different octant. बघा 2 डायमेन्शनमध्ये आपल्याला क्वाड्रंट मिळते 4. आता ह्यामध्ये 3 डायमेन्शनमध्ये काय मिळणार आहेत? आपल्याला ऑक्टंट मिळणार आहेत. 4 क्वाड्रंट असणार आहेत. बघा काय काय असतील यामध्ये. फर्स्टमध्ये काय असणार आहे? फर्स्ट क्वाड्रंटमध्ये ओ एक्स वाय झेड तिन्ही काय असणार आहेत? पॉझिटिव्ह. सेकंडमध्ये एक्स डॅश वाय झेड निगेटिव्ह प्लस प्लस. थर्ड ओ वाय डॅश झेड प्लस मायनस प्लस. नेक्स्ट फोर्थ वन ओ एक्स डॅश वाय डॅश झेड मायनस मायनस प्लस. फोर्थ ओ एक्स वाय झेड डॅश प्लस प्लस मायनस. सिक्स्थ ओ एक्स डॅश वाय झेड मायनस प्लस मायनस. सेवंथ ओ एक्स वाय डॅश झेड डॅश प्लस मायनस मायनस. अँड 8 ओ एक्स डॅश वाय डॅश झेड डॅश मायनस मायनस मायनस. Next is the one more theorem, last theorem. If a bar, b bar and c bar are 3 non-coplanar vectors, then any vector r bar in the space can be uniquely expressed as linear combination of a bar, b bar and c bar. You remember only statement of this theorem. If a bar, b bar, c bar are 3 non-coplanar vectors, then any vector r bar in the space can be uniquely expressed as linear combination of a bar, b bar and c bar. That is, see here, r bar is equal to, we can express r bar is equal to x a bar plus y b bar plus z c bar, where a bar, b bar, c bar are scalars. Okay, in this way we can prove these theorems. Here student, you remember the what is the collinearity theorem, statement of collinearity, coplanar and statement of that coplanarity of vectors. Then we see the examples based on this collinearity and coplanarity. We will see in the next video examples based on these theorems. So your today's homework is try to solve all the write the theorem statement and write the proof of also these theorems, and remember the statement of these all theorems. Okay, we will stop here. See you in the next video. Thank you.